So let's look at an example. We have these data points. These are, let's say, yield data. And we want to find out X bar, S2, and S, like meaning we want to find out the sample mean, sample variance, and sample standard deviation. So what are we going to do is that I wrote down on the board like the equations and like the final answer. Please try to do that by yourself. And if you had problem on calculating that, please let me know. It's just the first example that we can work on a statistic is like that. We are interested to find out sample mean, variance, and standard deviation. Also, let's say degree of freedom, because we work with degree of freedom when we want to read data from the table a lot, from any tables. So for the sample mean, we use the equation of the 1 over n and the sigma of all of the data points that we have. So, and when we do that, so we're going to put, we have 44 data points. Just add them divided by the 44. So we are going to get this, you should get this value, 62.768. And then for the variance, sample variance, if it was population variance, it would be sigma 2. Because it's sample variance, so we would say S2. S2, and then it's like that, the deviation of each of those data points from the mean, right? And then power 2 is a square. Then you will add all of those deviations divided by the degree of freedom. So it's like that, you have the sum of a square divided by the degree of freedom. Degree of freedom is like 44 minus 41, 43 here. So we will find out the variance of the sample. For a standard deviation, what would you do is that just simply get the square root of the variance, and it's going to give you the standard deviation. It's very important that we will, when we calculate all of these ones, we know that why we are interested in a standard deviation. Think about it. Whatever unit that you have for sample mean, the unit for the variance is going to be a square of it. Because of that, the unit of the standard deviation is going to be the same as the sample mean. So when we are later, we are talking about we are reviewing the confidence interval, you will see that. So when we say that, so whatever we find out in the sample, from the sample, like let's say sample mean, it's one of the parameters, right, that we find out. This sample mean plus minus the margin of error is going to give you a range for your population mean. So here it's important that we find out the standard deviation, because margin of error is going to be equal to the something from the table times standard error. When we want to find out the standard error, we are going to use this standard deviation. In fact, we would say whatever this S is divided by a square root of n is going to give you the standard error for the simplest case. We have 4 different cases. When you review when you review CHE 220, you will see that. After chapter 7, you will see these 4 different cases. And it's like that when we are interested in mean, we know the variance, that's case 1. When we are interested in the mean of the population, we don't know the variance, that's case 2. When we are interested, find out the variance, it's going to be variance of the population is going to be case 3. And when we are interested to find out the proportion, it's going to be case 4. So for each of these cases, we have different standard error. But for all of them, we need to find out the standard deviation. And then do something like put it in the, for example, for case 1, we are going to say that, okay, so sigma over a square root of n. For case 2, it's going to be sigma over s over a square root of n, and so on. So it's like that we need to find out this standard deviation to find out the standard error later. So it's important. So let's continue, and we want to look at the histogram of the data points that we have. So this is these are the data points that we have. And now, so on the board, I wrote down the result for the X bar, S2, and S. Here is the picture that we can see, like the histogram or frequency diagram. It's going to help us to know that, for example, if it has a bell-shaped curve or not, if we can go toward the normal probability or not, normal distribution or not, or for example, if it's skewed or not. So what are you going to do is that most of the time we try to connect the center of these beams, and then so it's going to be something like this, for example. In CHT 220 we had something about box plots, so make sure that you're going to review that one as well, because with the box and whisker plot or box plot, both of them you can call it, both of them are the same. So with those ones you're going to find out the outliers. So maybe this point is an outlier here, or maybe this point is an outlier. In that case, if we don't consider this, maybe we can have something like this, and it's going to be similar to the normal distribution curve. But with the box and whisker plot, we're going to remove the outliers with that technique. So make sure that you're going to look at it. It's on chapter 3 of the course notes that I put it on Learn.